In this problem, we're given a statement that is true. So 3x minus 1 is less than or equal to f of x less than or equal to x squared plus 1. So we're given that this is true, and they want us to find the limit as x approaches 2 of f of x. So we don't know what the original function is, so I'm not able to just plug the number in like that. So to do this by the squeeze theorem, we're just going to have to take the limit of each of these two things separately, and they should both be the same, and that should be the answer to our problem by using the squeeze theorem. So what I mean by that is we're going to do limit as x approaches 2 of 3x minus 1. And we're also going to do the limit x approaches 2 of x squared plus 1. So if I do this one, we can just put the 2 in there for x, so 3 times 2 minus 1, and that's going to give us 5. So we're going to do the same thing here. We're going to put 2 in for the x, so we get 2 squared plus 1, and that's also equal 5. So these kind of problems are set up in a way to where these should be both the same, because if they're not the same, then we can't use the squeeze theorem for that. But because they are the same, we can say since the limit x approaches 2 of 3x minus 1 equals the limit x approaches 2 of x squared plus 1, and that all equals 5. So since those two both equal 5, then the limit as x approaches 2 of f of x is also equal to 5 by the squeeze theorem. All right, so that's how you would do that. So you just find the limit of both of those, and then your limit that's asking for should be the same as these two numbers. And that's only because they originally told us this statement here. So this original statement is the important one they're telling us here, because that's the only way the squeeze theorem actually works, is when you have this g and your h functions set up that way. That's how we can conclude that the answer is going to be 5 by squeeze theorem.